Imagine standing on a planet where glass rains sideways, temperatures melt metal, and the air itself could crush you in seconds. This isn't science fiction. This is a real planet discovered by scientists. Welcome to the most dangerous planet known to humankind. In 2005, scientists discovered HD 189733b, a planet so lethal it could be mistaken for a sci-fi nightmare. Located 64 light-years from Earth, this hot Jupiter is known for one horrifying trait: glass rain driven by winds over 5,400 miles per hour. HD 189733b isn't just dangerous, it's aesthetic and deadly. Its deep blue color, once mistaken for oceans, actually comes from silicate particles in the atmosphere. These reflect blue light but carry shards sharp enough to slice through steel. At surface level, this planet's wind speeds surpass Category 5 hurricanes by several factors. Imagine trying to survive in winds 7 times faster than a jet plane. There's no shelter, no reprieve, just constant destruction. HD 189733b's temperature reaches up to 1,700 degrees Fahrenheit, 927 degrees Celsius. That's hot enough to vaporize aluminum and melt spacecraft in seconds. It's not just hostile, it's designed to destroy anything that enters. The planet is tidally locked, meaning one side always faces its star, creating a permanent day of fire and night of ice. On the dark side, sub-zero temperatures. On the bright side, instant incineration. Next stop, WASP-12b. This planet isn't just deadly, it's being consumed by its own star. It orbits so close that it's being stretched and distorted, like cosmic taffy. The star's gravity is literally ripping the planet apart, pulling off billions of tons of gas per second. It's like a giant straw sucking the life out of a once gigantic world. Scientists say WASP-12b will be completely gone in 10 million years, a blink in cosmic time. In its place, a ring of planetary ashes will orbit the star, a warning sign for future explorers. Its surface temperature, over 4,000 degrees Fahrenheit, 2,200 degrees Celsius, hotter than most stars' outer layers. Nothing can survive there, not metal, not life, not even the toughest space tech we've built. Due to gravitational distortion, WASP-12b isn't even spherical anymore. It's shaped like an egg, forever warped by the pull of its star. That level of stress alone would rip any solid structure apart. Despite its doom, WASP-12b has taught us about tidal interactions, planetary decay, and how deadly close orbiting planets actually evolve. It's a cosmic lab for studying planetary death. Let's talk about gravity gone wrong. Planet NGTS-10b orbits its star in just 18 hours, meaning it's inches away from being pulled into oblivion. One wrong shift, and boom, obliteration. Then there's Korat 7b, a lava planet. Surface temperature, over 4,500 degrees Fahrenheit. The ground is so hot, it's literally made of molten rock. No oceans, no atmosphere, just a sea of liquid stone. This planet orbits closer than Mercury, making it one of the hottest rocky planets ever found. Scientists believe metallic vapor rises into the sky, then condenses as metal rain. The temperature shifts on Korat 7b are violent. The day side is hot enough to vaporize rock, while the night side may be cold enough to freeze metal. This creates massive pressure waves across the planet. Imagine walking across that surface, molten rock under your feet, metal vapor in the sky, and crushing gravity pulling you down. Korat 7b isn't just dangerous, it's impossible. Next up, Gliese 436b. This ice planet is on fire, literally. Due to insane pressure, hot ice remains solid while its surface burns at 800 degrees Fahrenheit. It breaks every known law of thermodynamics. What you see isn't frozen peace. It's exotic ice under pressure so intense, it holds together even while the planet boils around it. This is what scientists call Ice X, a form of matter almost unknown to Earth. Gliese 436b is a reminder that alien chemistry doesn't play by our rules. Water, air, heat, they behave differently under extreme physics. It's a terrifying glimpse at what hostile life might look like. Another invisible killer? Magnetic death. Planet Jupiter has radiation belts so intense, they'd fry a spacecraft's electronics in hours. Now scale that up. Ultramagnetic planets like PSRJ 1719-1438b can do worse. PSRJ 1719-1438b is made almost entirely of crystallized carbon. Yes, a diamond planet, but it orbits a pulsar which emits deadly beams of radiation like a cosmic sniper. It's beautiful, but lethal. Those beams could sterilize anything in an instant. No atmosphere, no shielding, just raw exposure to radiation levels that would destroy DNA on contact. Some theorize that if Earth orbited a pulsar, life never could have evolved. These planets are death zones, where even robotic probes would last mere minutes before systems fail. Let's not forget Kelt 9b, one of the hottest planets ever discovered. Its atmosphere burns at 7,800 degrees Fahrenheit, hotter than many stars. The result? Vaporized iron and titanium floating in its skies. Kelt 9b is so hot, it may have no solid surface at all. Its heat creates a permanent atmospheric storm with metals in a plasma state, turning its skies into chemical chaos. The intense UV radiation is slowly tearing its atmosphere away, turning it into a streaming comet-like tail. This world is literally boiling off into space. Despite the chaos, KELT 9b gives astronomers a window into how extreme atmospheres behave. It's a furnace world, showing us how stars and planets can blur the line between each other. Now enter planet LHS 3844b, a planet with no atmosphere at all. Without one, there's no heat transfer, meaning one side burns while the other freezes to death. Standing here would be instant death. You'd either be boiled alive or flash frozen depending on where you step. LHS 3844b teaches us that no air means no balance, only extremes. Some of the most dangerous planets don't even orbit stars. They're called rogue planets, homeless worlds drifting through space, frozen, dark, and potentially full of ancient alien secrets. Rogue planets are pitch black, their surfaces possibly solidified oceans of ammonia or methane. With no sunlight, any heat must come from radioactive decay or core friction. Still lethal, still cold. And if something lives there, it would need to survive in total darkness, under extreme pressure, feeding off chemical reactions. These are alien biospheres we've barely begun to imagine. But danger doesn't always mean death. Some of these worlds might help us understand how life survives in extremes and how Earth itself might have started under similar conditions. So what makes a planet dangerous? Is it temperature, radiation, atmospheric chemistry, or the simple fact that we don't belong there? Each of these worlds pushes the limits of what's possible. What's shocking is that these aren't rare. The universe seems to prefer chaos over comfort. For every Earth, there might be 1,000 hell worlds. We are the exception, not the rule. These deadly planets show how fragile life really is. Earth is a cosmic miracle, perfectly balanced between fire and ice, shielded by just the right magnetic field, at just the right distance. And yet, even Earth faces similar dangers: solar flares, asteroids, climate tipping points. The universe constantly reminds us our safety is temporary and we must protect it. One day we may visit these planets, not with astronauts, but with AI probes, self-repairing machines, and quantum sensors. Understanding them may one day save us. Or perhaps one day our descendants will walk on them, adapted to the extremes, evolved for survival, becoming something more than human in the process. The universe doesn't care if we survive. Planets of glass storms, boiling metal, and invisible radiation remind us that space is not our home. Not yet. Every discovery out there tells a story of what we are not, and why Earth matters even more. So the next time you look up at the stars, remember, most of them are surrounded by worlds of fire, death, and silence. But we're still here, still asking questions, because danger doesn't stop curiosity, it fuels it.